All right, pre-calculus section 2.4, the law of cosine. I would recommend my classes to start looking down the road a little bit, maybe start nickel and diming the Unit 2 test review. Never too early to start nickel and diming those test reviews. You do not need to wait for the night before the test. That's not written anywhere. So anyways, let's get into this pre-lesson. This should be one of the shorter pre-lessons, so enjoy. So what have you learned lately? Well, you started with so katoa. Then the law of sine showed up. And all of a sudden, law of cosines? Why the need? So that's what I'm trying to answer this morning. So, or this afternoon, or this evening, or this late night, whenever you decide to watch. So here's your attack mode when you're trying to solve any type of triangle. We definitely, number one, would like to use SOHCAHTOA because it's just simple, and you're good at it, and you're familiar with it. Problem is, you can only use this for right triangles. Must have a right triangle. And that's the beauty of the law of sines and the law of cosines. Now, there's more coming as far as law of sines and law of cosines go, but we're going to start finding out that not all triangles are right triangles. Remember, you guys have been brainwashed in geometry. 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25, 30, 60, 90, 45, 45, 90. Pythagorean theorem always works for right triangles. So you got right triangles, right triangles, right triangles. That's not reality. So again, I go back to surveying a piece of property, and you're trying to figure out like the dimensions and the angles, so you can calculate the area, so you can calculate the taxes. You think some of this might be used once in a while? So let's take a look at this. Law of sines. It works on any triangle, but the question is, why do I need the law of cosine if the law of sine works on any triangle? Here's example 1 from your packet, so we're even getting a kickstart on your packet work. So we've got angle A is 115. We don't know side A. We know that side B, I'll just go ahead and label that, is 9, and we know that little c is 5. So let's go through our checklist. Hey, I want to use SOHCAHTOA. No, you can't, because you need a 90-degree angle in order to have a hypotenuse. And notice, you can use SOHCAHTOA only if you have a hypotenuse, so that's not going to work. So what if I wanted to use the law of sines? Remember, it's sine of angle A all over side A equals sine of angle B all over side B, sine of angle C all over side C. So remember what I taught you. You can use this, but you're only going to use 2 of the 3 fractions, but you need 3 of the 4 parts of those 2 fractions. A little bit of a tongue twister, but let's check it out. So look at, I know C is 5, so I'm going to put that right here. I know angle A is 115, so I'm going to put that right here. And I know side B is 9, so I'm going to put that right there. That's all I got. So as you can see, I know if I pick this fraction and this fraction, I only have 2 of the 4 parts. That's not going to work. If I pick these 2, I only have 2 of the 4 parts. If I pick these outside 2, I've only got 2 of the 4 parts. Guess what? It's not going to work. That means I'm going to be forced to use one of these. Now, number one, you can see they're a little bit more difficult, a little bit more to it. So you try to do this as last resort, unless you just love it. So, but look at it. So, don't I know angle A? So that's telling me this is the only one that involves angle A. So if I take this information and plug it in here, this is going to calculate everything that I need. But we'll do that in the packet. All right, you guys, that's it for the pre-lesson.